Hello, everyone. Welcome to the new episode of the OpenHW TV. As usual, we pre-record some of our content to give you better quality of videos and information. And then after 17 minutes this time, something like 17, 18 minutes, we will be back live to answering your questions and to have further discussions about the topic. Today's topic is about education and at universities using the PULP microcontrollers and the CV A4 and A6 cores from OpenHW Group. I'm together with Frank and Neil from ETH, and see you in 17 minutes. Hello, everyone, and welcome to the OpenHW TV episode 3 of season 3. I'm Davide Schiavone, and today we are going to talk about education and research with open source IPs, which is a topic which is not often discussed. I will be talking about the PULP and CV32E40P activities around this, whereas Niels from ETH Zurich will talk about the CV6 used for educational and research activities. But first, as usual, a short introduction about OpenHW Group. OpenHW Group is a non-for-profit global organization registered in Canada, and it's driven by its members. What we do is we are expert in developing open source industrial grade IPs. And today we are really specialized on RISC-V cores and all infrastructure around from hardware and software perspective. We have members from and developers from all over the world, America, Europe, and Asia. We have more than 80 members, including partners. And here in this slide, you can see many of them, but also academic members, which is the focus of today as ETH Zurich and University of Bologna. And along them, we also have partners, and partners help us to maintain the ecosystem and improve it. The way OpenHW Group is organized is via working groups. Working groups are actually taking care of high-level things like the technical roadmap and the marketing ones, whereas the task groups, part of the technical working groups, focus more on tasks. Like, for example, the core task groups focus on the development and the features included in our IPs, whereas the verification task group focus more on the verification of such features, and so on. We also have regional working groups and that focus more on activities related to Europe and Asia. So we have the European working group that, for example, implements digital sovereignty, participates to projects, and gather information about strategic and technological requirements and marketing for the European stakeholders of the OpenHW Group. And respectively, we have the Asian one that focus on similar things. So thanks a lot for listening to the introduction. Let's go back to our episodes. So now I'll talk about the PULP and the CV32E40P activities on education and research. So one main context where open source gets less light, but it's very important, is research and teaching. Indeed, open source IPs give free and easy access to universities to carry out educational and research activities, as they don't have to worry about the licenses. Research projects can be built faster, as there are plenty of available IPs that can be used as a building blocks for what they want to build. And also for teaching and learning, as the teaching activities as classes and lectures and exercises can rely on open source IPs. Here I want to give an examples that focus on research, and later I will give examples on teaching. So a real example is actually one coming from ETH Zurich and University of Bologna, which are actually the parents of the CV32E40P core. Back in 2013, University of Bologna and ETH Zurich had the idea, under the name of the PULP project, to explore energy efficiency at the edge and push the figures beyond the state of the art. So to do this, they developed their own the MCU with plenty of IPs. They tabled it out and did some research on it. And the byproduct of it was a list of IPs that they could open source on GitHub. The GitHub page was populated by, for example, RISC-V, Palpino, and other peripherals that they were used by other external users, as an example, other universities and other companies that will giving feedback to the repositories as there is this bug, can you please fix this? Or this is a fix for this bug, this is a new feature, and so on, such that the quality of that IP was increasing a long time. Then with new research goals that could rely on the existing pre-developed IPs were done, and to achieve the new goals, new IPs were developed, and again, later in time, released once the IPs were mature enough, open source on GitHub, making the database richer and richer. For example, in 2018, was then released the new MCU Pulpissimo, the new version of the core, a new cores, new peripherals, and so on. If we focus on the CV3240P, for example, here we can see the path from being an academic project, shown as a student in this slide, towards being an industrial IP. So RISC-V was born to replace the open RISC core of the PULP MCU to be compliant with RISC-V. Then it was extended with XPulp extensions to increase its computational capability, and then were released open source on GitHub. Once it was on GitHub, other users were contributing to it, as for example, providing a validator test bench, providing a little bit of verification and bug reports, architectural optimizations, and so on. Up to the point in 2020, where RISC-V was donated to OpenHW Group under the name of CV3240P, that were then maintained at industrial grade. The first step done at OpenHW Group was full coverage verification and bug fixes on a subset of the ISA, and as today work in progress, verification and bug fixes on the floating point and XPulp extensions. Focusing on teaching instead, we can see actually how ETH Zurich and University of Bologna are using CV3240P for classes. So for example, to introduce students to and teach students to computer architecture, the concept of instruction set extensions, or writing optimized C code for those IPs. For example, in this slide, we see an optimized 2D convolution that leverage the XPulp extensions to achieve top performance. Another activity organized by ETH Zurich to help universities and companies, or in general external users, to use the PULP IPs and CV3240P core is the PULP Training. The PULP Training is a 2-day workshop where the basics of the RISC-V ISA, the PULP architecture, and so on are explained. Plus, there is an hands-on session where actually people can learn how to write the optimized con and makes their hands dirty. Here in this slide, you also see a link of a recorded session of this PULP Training on YouTube. It's not only teaching activity and research in classes, but also projects. Projects as, for example, master and bachelor thesis or just short-term projects. So, for example, they are used to let the students learn on real-world IP blocks, such that they can learn it in depth or just use it as part of a larger system. And the outcome of those projects is often contributed back to the open source community, making that loop I was explaining before richer and richer of new features and new IPs and so on. To give a real examples, for example, the ISA extensions of the CV3240P cores were developed across several projects. For example, a short time project was implementing a single extraction, for example, the bit reverse to speed up the FFT algorithms, or a bigger project as a master thesis was done to develop the wall XPulp extensions on the core. Or, for example, to talk about another core as IBEX was used to develop the bit manipulation extensions. All these features are available today open source. Another recent project was also involving the same core, the CV32, on a bachelor thesis to actually implement the CVX interface to let the core communicate with external coprocessor, and in this particular case with the floating point coprocessors. And the outcome, again, is available in a branch of the core, but not only that, the activity of the bachelor thesis contributed to the interface specifications per se, making it more stable, more performant, and that can be used across other kind of ISAs. So thanks a lot for listening. Now we will listen to Niels from ETH Zurich that will talk about the CVA6 used for education and research. Thanks a lot.
Niels? Well, ladies and gentlemen, Niels is not here yet. My name is Frank Gürkaynak. I work with Niels at ETH Zurich, and we would like to talk to you about using Ariana or CVA6 in teaching projects. So first of all, let me give you a brief explanation of where we are. I'm from ETH Zurich, and we have been very active in open hardware. We are the largest technical university in Switzerland, more than 22,000 students, 530 professors. We are part of the electrical engineering department. There are 40 professors, more than 400 PhD students. And guess what? 100 years ago, Albert Einstein worked exactly at the same address. We are very proud of that. We are part of the Digital Circuits and Systems group. The boss is Luca Benini, and we are a large group of 60 people that all work around our flagship project, PULP. The Parallel Ultra Low Power PULP Platform project has started in 2013 and concentrates mainly on achieving energy efficiency. What we mean by that is that we are trying to build computing systems that can do more per battery, per joules available to them. How do we achieve this? Our key points are trying to do as much as possible parallel processing. We want to be able to efficiently switch between different operating modes. We want to make best use of technology, use heterogeneous acceleration, and most importantly, have an open source development using a permissive license. We have used PULP to design and test more than 50 chips. That makes us one of the most experienced groups in designing integrated circuits in the academia. We have wide-ranging collaborations with industry and other academic partners, and PULP-based solutions have been used in actual products. Part of this success is directly due to being able to use open source hardware that allows us to share and contribute between different partners easily. And here you can see a selection of our latest chips, which I think all look fantastic. And you can check out our chip gallery to see more of them or read about the details of what they do. The URL is asic.eth.ch. We believe PULP is for everyone. We have almost everything that we have designed available on GitHub using a permissive open source license on our GitHub page. We also have a web page that contains all the papers, presentations, and various tutorials that have been made using our systems. We have a YouTube platform where you can see training videos and demonstrations of the systems, and a very active Twitter channel where we provide people with up-to-date information and a little bit of fun with Bianca the bear, which is our cute mascot. Now, today we want to talk about Ariana. And Ariana started in 2017 when Florian Zaruba was looking for a master thesis. He was trying to figure out what would be something challenging to do in the group. Now, at that time, we already had designed several RISC-V cores, but they were all 32-bit cores. And Luca had very famously said, we will never, ever build a 64-bit core. Like a lot of famous things Luca has said, we actually completely ignored that. And only 6 months later, Florian finished his master thesis, and we had a brand new 64-bit Linux-capable core that we called Ariana. For us, that was a start of a new chapter and a very fruitful one that we used in several teaching projects ever since. Now, we will not go into too much details of the core, but here is a block diagram that shows a 6-stage single-issue RISC-V core that implements the RV64GC standard. And in June 2020, we were able to move the GitHub repository from PULP platform to OpenHW Group. Here you can see the original announcement by Rick O'Connor that announces the move. That was June 16, 2020. And guess what? Niels is here, and he will take over and talk to you about what he did with Ariana.
Thank you, Frank. I'm Niels. I'm a PhD student at ETH, and Ariana actually brought me to ETH. Now, how did that happen? In 2020, I was looking for a master thesis, and I came across the project on preventing timing channels on Ariana. The problem is that applications can leak data via shared microarchitectural states. Now, our solution was to partition that state by clearing it on a context switch. And for that, we proposed a new instruction, the fence-t instruction, which we implemented and demonstrated on Ariana. Now, Ariana was a perfect candidate for that because we could modify it, it was open, and this way we could bring up this idea on an actual core. After that, I started my PhD in 2020, and since then I've been involved in several student projects on and around Ariana. So how do we use Ariana in academia today? Ariana is a great research and teaching platform because the code base is entirely written in System Verilog, which the students learn throughout the VLSI-1 courses. It is well documented and easy to understand, even for students who have not had much experience with processes yet. Ariana has a very rich ecosystem, including simulation environments, FPGA flows, and SDK, including Linux, and many more. Ariana is open and modifiable, so it is a very nice environment and sandbox to try out new ideas and bring them up on an actual hardware. Now, in the past couple of years, there have been many student projects that used Ariana for their work and that were enabled by Ariana. Here is just a selection. I'm not going to present them too much in detail, but it is really incredible what was possible thanks to Ariana. And finally, the OpenHW Group support is very important to us. OpenHW Group maintains CVA6 at a very high level. So this allows us to focus on our research and the teaching. OpenHW Group aims at an industrial level verification of the IP, which makes us benefit from a much higher quality than we could ever manage alone. And also we can work on the projects that really matter. So we can find student projects that are relevant to the OpenHW community. And it is a win-win situation because those interesting projects often lead also in contributions back to the OpenHW Group. So this gives us a clear path to upstream new features and so that the students can contribute to real industrial applications. That's it from my side. Thanks a lot for listening and can't wait to see you in the Q&A.
So welcome back. I hope you enjoyed the presentation. Let's also greet Frank and Niels now live. Now we have the Q&A sessions with some of the questions I gathered offline, and we will also invite the people that are following to write questions on the chat here on Zoom, and we'll try to answer live. So I would like to ask if this record will be shared later on channel or email. Actually, all the presentations that we do in OpenHW Group are uploaded on YouTube, on the OpenHW Group channel. So if you type on YouTube OpenHW Group TV, you see the channels with all the previous episodes, and this one will be uploaded also in a few days. Here we also have Bianca the bear attending the Q&A session. So let's start from the one I gathered offline. Okay. So the first question is, we will be happy to hear a little about the historical perspective and future prediction for OpenHW. So for the historical ones, I think these episodes actually is where focused the most. So actually here we have Frank, so I let Frank talks about more about the stories as he knows way more than me. But basically OpenHW Group was born from Frank as well. It was a chat between Rick O'Connor, the CEO, and Frank, and that was the trigger idea, and actually starts from the needs of let's say an industrial organization that supports in the industrial way the cores that have been developed in the academia. But I let Frank populate more.
So to be honest, I mean, it's Rick made everything happen. So we were researchers. We were more interested in making our papers. We needed the course. We developed them. We were reasonably happy with them. He realized the interest in companies, and he called us one day. I was actually in Italy at the time at one of the workshops, and Rick is explaining this idea and said, "We will have the OpenHW Group. Are you willing to give or move some of your IPs to the OpenHW Group?" We said, Yes, why not? Let's do it. For us, it's great because, as Niels was explaining before, we don't have the capability, bandwidth, people to provide support in the longer run. So this is what open hardware really does. And there's a part of it where academic people like us are very excited about making new processors. That's great. But providing documentation and verification scripts, that's not where you get PhD students excited about. So, we have to do it to a degree, but it's not what you really want to be doing here. So this is also great when the Open Hardware Group took this into their hands and provided professionally. Jerome is asking a question.
So Jerome asked, what are the other open hardware initiatives for teaching and research? Well, teaching and research is always carried out by Open Hardware Group members that are usually universities or research labs. So it's not Open Hardware Group per se that does teaching or research. What Open Hardware Group is an ecosystem, basically, where all the member gathers together, focus on common path, common projects. They are into RISC-V, obviously, they are into open source. And what they do is they share their working hours, their manpower to build something that is at industrial level good for the whole community, not only of open hardware. Open hardware is the ecosystem where they get organized, plans, and things happen, let's say, formally in the same way towards common goals. But then the IPs or the scripts and the verification that happen, it's open source for everyone. And instead of initiatives for teaching and research, is actually that teaching and research, as I was saying in my part of the talk, can actually benefit from verified IPs as well. Research, because they can focus more on other parts of the design instead of debugging bugs that may be present in IPs that maybe are less verified. And teaching, similarly, you take something that is stable, working, where a lot of software is made available, verification is available, whether you're teaching software or hardware, something like this, in simulation, you get something open there. And basically what you do is maybe you remove an instruction and you let the student add it back, or you add the new instructions, or you write software for it. Eventually you have IPs that are available and you can freely use. So the gain of teaching and is on the freedom of access.
Yeah, well, but Open Hardware also supports directly some projects that Jerome is just writing, the CVVEC project, where we work with Poly Montreal. So this is also financially supported by Open Hardware. They are opening calls, and they will be, I think, extending these calls to others. At the moment, I think the organization is mostly around Canadian. MyTax is supporting it, so it is more on the North American continent with some additional things, but I think there are plans to also extend it. So this is the first thing that comes to mind. And what is also really helping is Open Hardware brings people together. So if you're organizing a workshop, tutorials and things like that, they reach out to their members and saying, look, there is date, there is, I don't know, HiPIAC, we are going there. Why do you also want to do something? So it also brings people together. So this is also one of the more interesting, it's really supporting people a lot.
Yes. The previous question was the past, and Frank said something already, and also the future perspective of Open Hardware Group in this regard. Well, the Open Hardware Group roadmaps as today is focused on always open source hardware, as the name suggests, and as today we are still and will be for a long time in the RISC-V ecosystem as well. So building more IPs like more core, more verification infrastructures. So RISC-V is also growing, like with new specs, for example, packet SIM, D-bit manipulation, the vector per se, as Frank and Jerome point out now. And what OpenHW does is building hardware for these new specs as well, not only as proof of concept, there are projects that are proof of concepts, but also at industrial level grade. For the other question, learning about the scaling of RISC-V system at the market level. Okay, difficult question, this one. I will interpret it like this, like how is RISC-V scaling like in products or so? Well, RISC-V is experiencing an exponential growth of people that are actually, and industries and research and universities, labs that are attracted to RISC-V. So if you look at the RISC-V story, they started few people meeting in Berkeley, and then now it's probably millions of or many thousands of people using RISC-V daily, both in internal projects, and you see now since the last few years products also based on RISC-V. Some of them are also based on actually the PULP ecosystem, and so what ETH and University of Bologna have built. And some are also based on the, let's say, on others, but we see RISC-V is actually growing, and OpenHW is growing with it. You want to add something, Frank, on the marketing perspective?
Marketing me? No.
We are not marketing people. But yeah, I would say RISC-V is growing, and you see that by looking at the companies that are using more and more RISC-V. Another person is asking, how about learning operator, I guess, instructions, how to learn how to implement instructions on RISC-V chips. So this is more on the teaching part of the topic. Yeah,
he did it, right?
Yes. We have. I mean, the core is open source and accessible. So in the end, it's about adding, first of all, the instruction and the decoder, and then the functionality, where depending, of course, on what the instruction or the extension is actually supposed to do. But I think it was fairly easy to start with these kind of modifications.
The Q&A was just posted. While many of the architectural research is at a C++ based simulation level, how do you think OpenHW Group and its ecosystem encourage research at RTL level? Any ongoing research ideas in the area at the RTL level suitable for a master's thesis? Well, just let me put it this way. I think most of the research most of the available things at RTL level at OpenHW Group anyway. So that is actually the, most of what is being done. The question, what can be done at a master's thesis, is actually not so easy. It is, we face it ourselves, like Niels was doing it. It requires actually of your supervisors to formulate it and have experience to see if this is something that would fit within however long your master's thesis is. At ETH, it's 6 months. So it must be something that one person can reasonably do within 1 year. So the thing that helps us at ETH is that we have more than 20-30 people here working actively on this, and they can supervise these projects a little bit easily. Now, the challenge when we sometimes have these questions coming from outside is, like, the ideas are there, but it also needs supervision. And when you do not have a group that is working on these things, has experience in it, you also do not find supervision so easily, and you will have to rely on material which is outside. There is a lot, but formulating questions that can finish within a given time is a little bit challenging. I have to agree on that. I don't know. Niels?
Yeah, I fully agree with that. I mean, there are plenty of ideas also on our project's website if you're interested in ideas. There are plenty of ideas. And then it really depends on the interests of the student and the scope of the thesis.
Yeah, we can make actually some examples of the thesis we had. For example, my master thesis was actually implementing the PULP extensions in one of our core. Wasn't RISC at that time, but it doesn't matter. But was extending the ISA, right? So other master thesis will be, for example, writing new APs. Florian Zaruba did Ariane during the master thesis. Niels also work on RISC-V. So it depends. Some others are more focused on, for example, chip implementation, but still in the RISC-V ecosystem. But because of ETH has a lot of experience and on SoC's design, maybe they get IPs pre-developed and they focus on the implementation of it to reach other corners on the PPA, on the power performance angles, or others maybe like in software. So still working on RISC-V, but writing optimized libraries for artificial neural networks, for health applications. So for example, at University of Bologna, they have a lot of applications that are on the EEG. So they are a little bit far now from the RISC-V. It's still a master thesis, but they are using RISC-V. Like they are writing C that runs on RISC-V. So you see the whole spectrum from writing the actual IP to actually implementing in silicon or just using it on the software side, on the compiler side, and so on. There are many. And actually, as it's not really super related to this, but similar to connect also to the previous question of how do I learn to implement an instructions? Those, for example, are not master thesis. Let's say an instruction probably is too little for a master thesis, at least according to our experience. But what one can do by himself, for example, both Ariane and RISC-V and many of these IPs come with validator support, like they compile with validator, right? So independently, you can run some RTL simulation and get your hands dirty by yourself with tutorials and with materials that is available open source, open on the web. As Frank said, maybe there's no a single page to look at where it's written how to, but there's plenty of material and possibilities to do it. Maybe it's actually an idea how to, right, and how to we gather a little bit of information together. Why not?
But for example, Ariana is the trick when you add instruction set extensions is that you also need the compiler chain to support it. So that makes it difficult because all of a sudden you were booting Linux, but now your new processor has additional instructions and you need to essentially create all the software ecosystem, not only just a compiler, to have this support. So that makes it a bit challenging, but it would be like Ariana therefore is fully or stays compliant. And then you can make a trial, right? You can say, why doesn't Ariana have an instruction that does some weird multiplication? And you can just implement it and compare against the version where it didn't have. So it's a great learning tool because the thing is working and you can go and change everything in it. You can say, what if Ariana had 40 registers, about 40 is not smart, 16 registers instead of 32? Will it be much smaller? Can I still write programs on it? How much longer will the execution take because there are not enough hardware registers, et cetera, So it's great for playing around.
And maybe also to add, it's not only about changing the interface between the hardware or the software, which is, I think, a very exciting thing, but there's also more to it. You can also have architectural improvements for Ariana, so things that do not necessarily change the interface to the software, but for instance, caching, etc. So there's also lots of things to explore and discover, or also use Ariana as part of a system on chip, like adding a video output, etc., which also do not modify the core directly, but use it as part of a system.
That's one of the projects, right?
Yeah, it is. This was actually one of the projects. Yeah.
We wanted an HDMI output so that, you know, we can make the presentations with the Ariana thing.
So the presentation is actually the outcome of the master per se.
Yeah, exactly. If you can present it, if the pictures look nice. Jerome is commenting on the is your frame buffer open source? Yeah, everything we have is open source. Is it? But the frame buffer is not that great at the moment. It's still work in progress, man.
Yeah, I think the frame buffer is still work in progress. Yeah, but I would need to double check on that.
So it's ongoing work, but we want. So this is also a comment from Jerome. We use a permissive license that makes it easy for companies to adopt it. There are basically two types of licenses, right? You have what you call reciprocal licenses. You can only use the open source in your projects if you either contribute back or make that part that is used also under the same license. GPL is the most famous one. And then there are permissive licenses, which is more or less you say, here it is, take it, do whatever you want, we don't care. So the reciprocal licenses, GPL and the like, are very difficult for companies to accept because they have to make sure that there is no pollution of this into their own business practices. So they stay away from it, and it's understandable. I mean, on the other hand, permissive licenses are great. They can just take it. They know how to deal with it. They are agreed to the licenses. However, you are not getting, let's say, the contributions back. So this is why people that want reciprocal licenses and say this should be the only way to do it are upset because they're saying a big company in France, for example, takes our things and they don't contribute back. So now OpenHW is actually closing the loop because now companies actually donate resources and manpower, money, so that OpenHW can develop things. So essentially their let's say reciprocity is not coming through enforcement through the licenses, but they see that the licenses are good, they can use it, they have an interest in making sure the product is better, and OpenHW is the thing that closes these things. So that's actually a very good combination. You're not trying to let's say release your things open source that companies don't take, that nobody actually uses. It sort of stays open, but you cannot always generate a community like Linux did or GCC did. When it works, it's great, but you cannot always make it. This way, permissive licenses allow the companies to be involved in it. And if a grouping like OpenHW comes, the loop actually closes. So what you were losing through reciprocal, not using reciprocal licenses, end up helping you.
Yeah. We suggest this model, but as you said, it's not forced because of the license doesn't say so. Yeah. Also, still to just the last comment, just to stay on the teaching side as before, ETH actually also organized for those who were asking, how can we start from scratch? Like, I want to start from scratch. I don't know where to start from. I know nothing about RISC-V, OpenHW, PULP, nothing. Where shall we start? Well, one, as mentioned during the talk, one of the idea that we, when I was at ETH, we organized was the PULP training, which was, or is actually still alive, 2 days workshop, or sometimes it's only 1 day, where the basis of the RISC-V ISA and the cores are explained, and if it lasts 2 days, we also have the hands-on session where we show how to write code for it. In some internal lectures also how to modify the RTL of it, but that was more for the internals. And this is also available in the PULP platform page. There are plenty of trainings. The first one was about the embedded class cores, which were the oldest ones, the more mature ones, and RISC-V basics. Plus, we added many more with also other PhD contributing, and this is teaching materials for free related to these topics, available at the link Frank put in the chat.
About like 20 hours of videos or 15 hours of videos there. So it's not little. There are also the slides. One of them also has, I think, a VM image, which is quite large, but you can get going directly. Also on the same web page, there are all the talks and slides we have. Some of them come with videos, some of them not. The papers, as much as we can, we put the open versions also on the web page, so you can link from there. So there's actually plenty of information apart from let's say Bianca and then some cute pictures.
So plenty of materials available. Okay, I think we don't have any other questions. If Frank and Niels wants to add something, please do it.
Well, there are people following live, so it would be great if we can answer questions from them. I mean, a couple of them I think I know.
So please feel free to ask questions here in the chat. So otherwise we need to leave.
We need to leave. We
have to leave.
Maybe one thing to add would be also to be encouraged to have a look at the repositories and browse the code and the documentation, and reach out if you have also questions.
Yeah, I see a question now from Sergey. I'm an engineer and student in European University in Armenia and interested to join in RISC-V research project. So that's great, but technically speaking, RISC-V is not a research project. So RISC-V is an open ISA. People can work and can develop their own processors. But RISC-V can be used in your own research, or you can use RISC-V as a tool to build something larger, and it doesn't tie you to a vendor directly in your project. You don't need to have agreements directly to be able to do it. Yet the hardware description is available, sometimes open, like from Open Hardware. There are also commercial providers of RISC-V cores. So, but research in RISC-V is, it's not directly a research project, right? The research is your research. You may make use of RISC-V in your research. You may use it as part of it, or your research just needs a processor or some ecosystem. You are more concentrated on your own work. Just to make it work, you need some sort of processor. You actually don't care what it is. And RISC-V happens to be a readily available, nicely working system that you can make use of. So it's important to not think of RISC-V as a global research project where people are contributing and things. There's also this thing that, it's good, people get excited. They say, I'll make a much better processor. And it is possible. However, just consider that a lot of people are actually working on it. So a number of things are actually being covered, let's say, rather decently. It's not like there is a burning need to make a better multiplication in RISC-V. But what is, for example, what Open Hardware, sorry. And I have planned to establish FOSS-SOC design workgroup RISC-V based. Yeah, that's great. Actually, there was a lot of activity in Armenia, especially Synopsys has, I believe, a big group in Armenia. They actually produced a lot of the tutorials, Synopsys related, standard cell design. So they had the group was Synopsys Armenian Education Design Group, SAED or something like that. So over there at Armenia, there's actually a lot of activity. I'm pretty sure if you are locally establishing something, we have had a lot of very interested people from there. So if you have questions, if you are stuck, if you want to have pointers or so, drop us a line. And if we don't answer back, let's say within a couple of days, just send it again. It's just that sometimes we have a buffer overflow with emails. So I'll just type the And if you have, I don't know, $50 million that you want to send to me and I have a lottery, please use the same email. Everybody seems to send me this. So why not another one?
Yeah, there's one from Shrihari. Is it? I hope I pronounced it correctly. So there is a computer architecture project developed the OpenHW Group IP, the CVX interface, which is, by the way, also coming originally from ETH in BSV and integrated in a proprietary processor. Now I'm planning to pursue master and willing to contribute to OpenHW ecosystem. For this, should the university or I will be joining, be a member of individual collaborators are possible? Well, if your university joins OpenHW, it's possible. It's super cheap for university. I think the minimum is $1,000 per year, which is usually affordable for the universities, and the whole university then can participate to OpenHW Group projects and so on, and collaborate with other universities and so on. Not that is a must, but it will be better for engaging with the other members. Also, individual collaborators are possible anyway, but we encourage an university level participation.
Yeah, okay. Let me just be the counterpoint here. Rick will be upset with me, but both RISC-V and OpenHW Group and CHIPS Alliance, they don't really understand the universities so well. It's not their fault. They don't have too many people in universities in the decision-making process. 1,000 francs or $1,000 may not be too much for a larger university like ETH. But this is not nothing, and you have to find continuous funds. Trying to get one department to pay $1,000 US every year, it's like a significant administrative challenge. So people have to see that individual contributions are always possible. And if you are working in a group that has actually a large interest, wants to, if you have a group of 5, 8, 10 people in your university that is doing that, maybe that group has large enough of a scale to be a member, but individually probably trying to, as a master's thesis student, trying to go to your professor and say, why don't you pay $1,000 to be a member of OpenHW Group is going to be difficult. I think I see the problem. And individual contributions will always be possible.
But anyway, you can contribute to OpenHW Group even if you're not a member. I mean, pushing to our repositories is allowed. Making pull requests is allowed. It's not that you don't have to be a member or so. Just to be part of the ecosystem means participating to meetings, synchronizing non-common activities, etc. But everyone can use and contribute to open source IPs. That's the open source nature.
You won't be able to, let's say, influence some decisions, or you won't be able to head a working group or something like that. Individual contributions are possible. I believe they still have to sign or have the Eclipse contributor license agreement so that they agree with this.
Yeah. Well, we have examples of people that are not part of OpenHW Group that were using exactly the CVX interface, or exactly the same examples from another universities, and they found bugs or improvements in the spec, and they suggested opening issues or directly making a pull request. Then, of course, you cannot merge in. It must be a person that is allowed within the OpenHW ecosystem, and then it's up to him or her to accept the pull request, and then you contributed, right?
I mean, one good part also for checking what to do is actually just check the issues on individual projects on the OpenHW Group or on the PULP platform GitHub to take a look at what issues are open, what people have reported, and something might be interesting for you. And we open issues as well. We open issues so that we can track them, and we realize, hey, at some point we need to do this. It's just that nobody has time to do it at the moment. So looking at issues on GitHub, on these repositories is actually a good way to see where can I do something that people need, because they already said, I need this. There's an issue. It would be great if I could do this and this and this. And you can start a discussion directly on the issue thing, make a follow-up, ask for more information, or say, hey, I have time. Where do you think I could contribute, and things like that?
Yeah, and the good thing about the GitHub issues is that they are open, visible also to everyone. So in case there is someone else also interested in a similar problem, you might find some mates or some. Yeah, it's a good platform, I think, for discussing those issues.
There's one thing, maybe this doesn't fit into the thing Sergey is saying, FOSS EDA, so free and open source software EDA to university. It's a difficult topic. I mean, open source hardware is something, open source EDA tools is something else. They don't necessarily overlap. So it's a different topic, and you understand why it is. I can tell of someone who's really interested into open source. I understand why the EDA is a bit more problematic. Not saying that it is something bad, but using it at the university can be a bit more problematic. So but it is probably a different topic in discussion.
Yeah. Okay, I think we are in almost 5 minutes to quit on top of the hour. So I think if there are no other questions or comments, we can finish here. Thanks everyone for listening. Reach out to me, Frank, and Nils on our emails, or commenting under the YouTube video once it's uploaded, or every other channel you prefer. Thanks a lot, and I wish you a good evening or a day, depending on your time zone, or night. Thanks a lot.